Hey folks, welcome to lab number 5. We are going to talk today a little bit about abstract classes and about polymorphism and how they are related to each other and how we can go about using them. So for today's lab, I'm actually going to use the same lab that I had last week from lab number 4. And what I had created last week, just as a quick refresher, I had I had set up a person class which had an employee and a student as children, and also the student class then had two children, which was undergrad and grad. And then we had some attributes and some methods that had inherited their way down here. So using this diagram, I just want to talk about this for just a moment. You are an example of probably an undergrad. So we know that there are undergrads that exist out here. You might also be a grad student. We know that they exist. As a matter of fact, your GTA is a grad student. And so we know that there are students that exist here, either undergrad or grad, and we know that there are employees, because I'm an example of that. But with regard to the concept of KSU, what is a person? Like, you're either a student or you're an employee, or you really shouldn't be here. Maybe you're a visitor. I guess that would be the third class that you might want to have in here. But there's really no person. There is employee or student. So the question is, would you ever actually make an instance of a person? And I did that in my main program. So if we go back over to program, you notice that right here I made an instance of person P1. And that's okay because I'm allowed to do that at the moment because person is a class. The question is, should I be allowed to do that? All right, now this is a little bit confusing because you might say, well, I'm the person writing the code. Why would I ever want to stop myself from doing something? That doesn't make a whole lot of sense. And that's true as long as you're the only person working on the code. But that's not how it works in the real world. When you get hired at a company, you're going to work with a lot of other developers. If you're in a game company, for example, maybe there's going to be 200 developers, and they're all going to be working on the same code to make the same game work. And so there has to be rules about how people are able to edit things and how people are able to change things. We already saw one example of this when we talked about the virtual keyword in person last week. We said that there might be a circumstance where the manager of a team might want to stop the employees on that team from changing daily routine. Maybe daily routine must be the same for all of the people that are in that class. All right, so this is another part of that same thought. If we were thinking about something like a video game, you might have the main character. Let's imagine it's a first person shooter. And then you may also have the bad guys, right? So you walk into a room and then bad guys appear in the room and then you have to kill them. So the bad guys may be of different kinds. In some rooms, you may end up with robots. In some rooms, they may be zombies. In some rooms, they may be monsters. In some rooms, they may be dogs. I have no idea. So all these different types of bad guys show up that you may have to kill. So how would they go about coding all of that? Well, each bad guy would have a lot in common with the other bad guys. So, like, for example, all bad guys would have to know how to be hit if they get shot, which takes away some of their health. They would have to have a health that they keep track of as to how alive they are effectively. And every time they get hit, that life would go down a little bit. Maybe there's ways that they can rejuvenate in some way. So there might be a set of methods and attributes that are specific to all bad guys. So either each bad guy, as it's being written in the game, would have to re-implement and redefine all of those things, which doesn't really make sense because you don't want different developers having to recreate the same thing over and over again. Or you would put all of the things that they have in common in a parent. But then what would you call that parent? Because you have zombies and you have bad guys, or sorry, you have zombies and you have robots and you have whatever else. The parent of all of those would just be bad guy, right? And so you would have a class called bad guy, and then you would have all the children underneath it that actually really exist. So then, would you ever walk into a room and face a bad guy? No. You would face a robot, or you'd face a zombie, or you'd face whatever it is. You'd face one of the children, but you'd never face the parent. And so what would happen in that case is the parent would be marked abstract, which means it's not a real thing that can be instantiated in the game. It's just there as a placeholder to hold all of the children underneath it. All right, so back to this example that we've been looking at here. Person, in the context of KSU, is not a real thing. You would never actually make an instance of person. You would make instances of employees and students. So what I'm going to do is I'm going to go to person, and I'm going to say abstract class person, simply putting the word abstract on front of it, and I'm declaring that this class cannot actually be instantiated. So this is immediately going to cause a problem over here in my main, because right here I tried to instantiate person, and immediately now when I underline, or it's underlined, when I mouse over it, it says cannot create an instance of an abstract type or interface person. So this is telling me that this is no longer allowed. If I try to compile, I'm going to get compile errors, and it's simply not going to allow me to do it. Inconsistent access, base class student is less accessible than grad student, cannot create an instance of abstract type or interface person. So I'm going to turn this off, and that means that I no longer have a P1, so I have to turn off all the places that I had a P1, but now everything else works the same. So specifically, my person class had a method called daily routine. And in my student, I overrode daily routine, but in my employee, I didn't overwrite daily routine. So let's go back to to the main program, and I have created a student S1. I'm going to make an employee. Employee E1 is equal to new employee, and I'm going to set E1's name equal to Enda. And I can call E1's daily routine. All right, so if I run this, all that works fine, even though the abstract class, all right, so it's unhappy with the fact that student is less accessible than class grad student. And that's because I'm going to make this public class student, and grad student should also be public class, and undergrad should be public class. There we go. Just need to be consistent on all of that. They should probably, most of your classes should be public. All right, so now I believe that's going to be happy. Build started, failed, inconsistent access, class person is less accessible than student. Yep, probably didn't do that here either. All right, now are you happy with me? Yes, looks like you are. Okay, so back in my main method here, I created a student and I created an employee. And both of those are children of person, but person is now abstract. Person had a definition for daily routine, and when I called daily routine on employee, I got wake up, watch cartoons, eat, and sleep, which is the definition from person. That's what was in here. So the point here is, even though the class is abstract, I still get access to all of its methods and all of its attributes just the same as if it had not been marked abstract. The only thing that the keyword abstract really changed is I am no longer allowed to instantiate person. So that's the idea of an abstract class. It's a way to aggregate a bunch of information that all of the children of that abstract class are going to need to inherit. In the example that I gave about bad guys, the bad guy class, abstract, but has information about, how much hit points you have and what you would do when you get hit and when you die, and all of those things would be defined up there. And then each of the children would inherit that and only change the bits that they need to change in order to function as a robot or a zombie or whatever it is that they need to change. All right, so hopefully that's the idea of an abstract class. So the next topic, which is related, is polymorphism. So polymorphism is the idea that there are some times where you might want to be able to store a bunch of these employees and these students. So let's imagine that I wanted to create an array that had everybody in KSU in it. So we know that KSU is made up of students and it's made up of employees. The students could be undergrads or grads. The employees, there's no children classes there at the moment. If we take a look at that class diagram, we can see that person, which is now an abstract class, you note that it has updated that. And then we have employee, student, undergrad, and grad. So what I want to be able to do is I want to be able to store everybody in one single array. So my first thought there might be to make an array of students. So I'm going to say student, and then I'm going to say our KSU students equals new student. And there's about 45,000 of you. Okay, and then I might have an array of employees. And there's about 5,000 of us. All right, so that works, but I now have two separate but very related arrays, one that holds all the students and ones that holds all the employees. And that's not exactly what I wanted. I wanted one array with everybody in it. So how can I do that? I could say person array, KSU all equals new person, 50,000. All right, so that's goofy. I'm using person as a type here. Just like I was doing it up here, when I said person P1, I'm using P1 as a variable name, and the type of that variable is person. And then I was instantiating a new person on there. I can still use an abstract class as a type, I just can't instantiate new instances of person. So how would I go about using this? Well, we've created an S1, this student up here, and I've created an E1, which is this student here. So I can say KSU all, which is the name of this array, at position 0 equals S1. KSU all at position 1 equals E1, which is the employee one. So that's weird. In this array, the first cell holds a student, the second cell holds an employee, and so on and so forth. And I can mix and match as often as I want between the parent or between each of the different children. I could even create an undergrad. So we'll do undergrad, U1 equals new undergrad. And then I can say KSUID or KSU all at position 2 equals U1. So now the first cell has a student, the second cell has an employee, and the third cell has an undergrad. And again, I can mix and match. I can put as many of them in there as I want. This isn't limited to regular arrays. I could have done this with a list. So I could say list person, all KSU people equals new list person. Right, and you remember that you're going to need to alt enter on that in order to be able to include system collections generic so that you have access to a list. But this is the same as the array up here. Now I just have something that grows and shrinks dynamically that can hold employees, students, undergrads, grads, all the rest in there. The only thing I cannot do is I still cannot make a new person and put them in there because person is abstract. So this is a very common use of polymorphism. It's creating a structure that is of the type of the parent so that I can put in all the different types of children in there. Back to the video game idea, there may be an array of bad guys. And then in the array, the first thing might be a zombie, the second thing might be a zombie, the third thing might be a robot. And when you come into a room, effectively all that happens is it spawns all of the new bad guys that need to be created. So it instantiates a bunch of zombies, a bunch of robots, or a bunch of whatever, and it puts them into the array that keeps track of all of the zombies. Each one would have a location on the map as to where they are, so that if you walk away and come back, they're still there, unless you kill them, in which case they go away. And as you walk into new rooms, new zombies are created, new monsters, new robots, whatever, they're all created and added to the array list. And then each of those objects is sitting there in the bad guy array list. The bad guy holds all the different kinds of bad guys. So that's the idea of polymorphism. To be clear, it's not only possible with arrays and with array lists, with lists. You can also just directly create an object that is polymorphic. And so what I'm going to do is I'm going to say person P1 equals new student. Now that's really goofy looking because normally every time I've done this, I've said undergrad equals new undergrad, employee equals new employee. Typically what's on the left and right side of an instantiation statement are the same. But here what I'm able to say is the type of P1 is going to be person, but what I'm putting on there is a new student. I cannot put a new person on there because it's abstract and I cannot instantiate abstract classes. But student is a concrete class, and I can absolutely instantiate it, and I can store it on the parent. The rule is you can't do this in reverse. I can't say student S4 or S5 equals new parent person. That's not allowed. It's actually not allowed for two reasons. One, I can never say new person because it's abstract. But even if I was able to do that, let's do undergrad gets new student. That's not allowed because student is not a child of undergrad. It's the other way around. Undergrad is a child of student. So this is not permitted, but this is permitted. So hopefully that makes sense there. All right, so all of that is the definition of abstract classes. We've talked about polymorphism and how that relates and how you might make an array of different objects. And hopefully that will get you started on today's lab. And you guys will have a lot of fun with creating polymorphic classes and putting them in array lists. And I will see you guys next week. Take care.